Hey guys, it's Casey from toomanymiatas on Instagram again. I'm making this video because I ran into a weird issue with my car where the ECU was no longer receiving power, and I essentially had to diagnose and figure out what kind of circuit on the Speeduino PCB might have went wrong and had an issue that was no longer making it to where my ECU would receive power. Car wouldn't start, fuel pump wouldn't prime, all sorts of bad stuff. So essentially this video is going to be kind of a guide and a tutorial on how to use a program called Fritzing to basically diagnose and analyze the PCB, kind of trace circuits and wires and all those kinds of things. I like to think of Fritzing as kind of an AutoCAD for electronics projects, to where it kind of lets you drag and drop components onto a kind of like a workspace, and you can run wires and create a schematic and a diagram. You can actually create a PCB directly from the program as well. You can also create kind of breadboard circuits. It's basically an AutoCAD for electrical projects is honestly the best way to explain it. Now, you used to be able to download it from Fritzing's website, but they kind of made it to where they want to try and encourage people to donate in order to download their product. So now you can actually download it just from another website called Electro Schematics. I'll put a link in the description for this download, that way you guys can download Fritzing's yourself and make it super easy. The reason we want to download Fritzing in the first place is because Josh Stewart, or Noisy Mime, the creator of Speeduino, actually made it super easy for us to kind of trace wires along the PCB of our ECU by using Fritzing to open .fcz files, which are Fritzing files essentially, and we're able to open up kind of the AutoCAD workspace equivalent, almost, if you want to call it, of the ECU that he was working on when he was creating this project. That way we can kind of trace wires and trace circuits and look at schematics and all of that sort of good stuff to try and figure out what could be wrong with our ECU or what could be causing the problem that we're running into. Once you've downloaded Fritzing, you've got a couple options in order to get those .fcz files. You might actually already have them downloaded if you've already downloaded some Speeduino firmware versions before to install on your ECU. But if you don't have them downloaded, then you can always go to the Speeduino GitHub, and whatever firmware version you have, you're going to go to that firmware version, and then you're going to go under Reference. And under Reference, you're going to find the hardware folder. Under hardware, we're going to have all the different ECUs that he's created, and then you're going to find whichever ECU you have. Mine's going to be an NA6 plug and play. You're going to go under there, and once you're there, you're going to find the .fcz file for your ECU. Go ahead and download that .fcz file. Once you've downloaded your .fcz file, you're going to want to open it up using Fritzing, and once you do so, the first image you're going to be greeted with is this image after all the parts load. It is going to look kind of crazy and kind of hectic, but essentially this is kind of like a breadboard view. It's a physical representation of all of the parts that are on the ECU. So if you ever kind of want to look at what the part would physically look like, maybe it's the Arduino itself or any other part, you can use this view to kind of see those parts. Another view that you have as well is the schematic view. And the schematic view allows you to view kind of the data sheets and the pinouts for all of the different components that are on the board. And then you've also got the PCB view, which is going to be our actual ECU. This is going to be the PCB that is located in the housing that, you know, the wiring harness connects to and is essentially what controls our entire car. And then you've even got a code section, but this usually doesn't have any information in it unless you actually connect it to your Arduino IDE. This PCB viewpoint is actually going to be the main view that we're going to be focusing on today. If you'll notice, every single wire seems to have a little circle at the end of it. Whether it's green or red represents if it's powered or not powered, I'm pretty sure. When you click on one of these green circles, it'll actually highlight all of the other circles and all of the other wire endpoints in the circuit with yellow. That kind of represents where those wires are connected to and what it's connected to in the circuit. So for example, we can go over to one of the main connector pins for the ECU and just click on any of these circles, and it will highlight every single little pinpoint in yellow that those wires are connected to. That way you're able to use this PCB view and kind of follow the wires and see maybe what component could have went wrong, figure out what component could be bad, all those kinds of things. I'll actually be showing you what I had to do to figure out why exactly the 12 volts that was coming into my ECU was no longer being turned into 5 volts. The reason I was able to tell that my ECU was not turning its 12 volts into 5 volts was because my ECU actually has a Bluetooth sensor on it that I wired up, and that Bluetooth sensor wasn't turning on when I turned the key on. When I turn the key on, the ECU should be receiving power, but for some reason that power wasn't turning the Arduino on, which then wasn't turning on my Bluetooth module. So, for some reason, I had to figure out why my ECU maybe wasn't receiving power or wasn't turning that power into the power that it needed. In order to figure that out, we had to figure out which pin on the ECU would be receiving power from our battery. And in order to figure that out, we need to find the ECU pinout of our ECU. Here's the ECU pinout of an NA6 Mazda Miata. And the power pins on this ECU pinout are actually going to be over here. They're going to be pins 1B and 1A. 1A is going to be constant 12 volt power from the battery, while 1B is going to be switched 12 volt power from the battery. And that switch is going to be our ignition switch. Thus, in order to check and see if our ECU is receiving power, we can go and grab a voltmeter and check pins 1A and 1B to see if they're receiving 12 volt power and switched 12 volt power respectively. Along with this, we've got blue red and white red indicating the colors of the wires. That way we can 110% make sure that we're checking the voltages of the correct wires. I'll leave a link in the description to this pinout in case anybody else needs it, but Google will be your best friend in order to look up any sort of pinout that you could ever need, essentially. When I checked these pins on my car, I found that 1A was receiving 12 volts and 1B was receiving switched 12 volts. So at that point, I was at kind of a loss. I was like, what could be causing my ECU to receive power but not turn that power into whatever it needs to be? And at this point, I wasn't 100% sure what the voltage regulator circuit in the ECU was, but I was able to use some Googling and the program that I'm about to show you called Fritzing to figure out that 1B, our switched 12 volt power, actually goes directly to an integrated circuit on our ECU that is then turned into 5 volts. So, we know our ECU is receiving constant 12 volt power, and we know it's receiving switched 12 volt power. We just don't know why that switched 12 volt power isn't able to power our ECU. So, if we go over to our ECU and check out pin 1B, just like we were checking out on the ECU pinout, if we hover over the pins, the 48 pin circles over here, which is going to be our ECU connector, we can find that this little circle right down here is going to be 1B. And like I told you guys, when you click on these circles, it'll actually highlight in yellow all of the other connections on the PCB where that pin is making a connection with that component. So 1B looks like it makes a connection to a little 12 volt pin out, it makes a connection to the DRV stepper up in the top right, it makes a connection to a couple different resistors, and if you'll look in the bottom right, it actually makes a connection to IC7. And if we move our cursor over to the point on the IC where it was connecting to, we'll see that it's connecting to pin 37 on IC7. So it looks like there's wires that go from pin 1B on our ECU pinout to pin 37 on IC7, and that's our switched 12 volt power. So once we figure that out, we've got to figure out, okay, what is this IC7? What is this integrated circuit? And in order to do that, we can actually go all the way over to the schematic in Fritzing and then zoom in to IC7, which is going to be right over here. And when you zoom into IC7, we can go ahead and look at pin 37, which is going to be what we were just seeing, which was the 12 volt switched power, and we'll see that IC7 at pin 37 is key switch, so that's going to be the switched 12 volt power that comes into IC7. So now we've got to figure out what exactly this integrated circuit's doing. So, in order for us to figure out what exactly this integrated circuit is doing, we're just going to need to Google the MC33814 part number of this integrated circuit and pull up a datasheet to figure out what exactly it says it's doing. When we do that, we'll pull up this datasheet, which is going to have all the sorts of pinouts and diagrams and all sorts of useful information that we'll be able to use to figure out what exactly that pin key switch that we found on our PCB is actually doing. So if we pull up this datasheet and Control F key switch, let's see what we find. The first thing that we find is the startup, shutdown control, and power secret logic with key switch input. So essentially, key switch has something to do with the power input logic. So then let's go down to the pinouts and see what the pinouts say key switch actually does. So then if we go down to this key switch pinout description, we'll see that when key switch is on, the IC is enabled, and then bat switch is pulled high. And what it means by bat switch being pulled high is that bat switch is giving power. Now bat switch, let's figure out what bat switch does. Now if we search bat switch on the pinout, we'll find bat switch is an output of 5-volt logic level that is high when key switch is high. So essentially, that 12 volts 1B switched power that comes into key switch is then turned into 5 volts with this integrated circuit and sent out of pin bat switch. So then we know that our integrated circuit needs to have 5 volts power coming out of pin 29, aka pin bat switch, and then we can figure out if that pin is actually receiving the 5 volts like we're looking for. Arduinos actually run off of 5 volts, so we can essentially assume almost that if that is what's supplying 5 volts in our ECU, that's probably what's supplying 5 volts to our Arduino, and that's probably why our Arduino isn't receiving power. There must be some sort of an issue in that integrated circuit that's causing that switch 12 volt power to not turn into 5 volt power. So now we know that when key switch, our switch 12 volt power, is brought to 12 volts, that it should also bring bat switch, pin 29, to 5 volts. So let's go ahead and find pin 29 on our integrated circuit. And when we do find pin 29, what we'll actually find is that it doesn't go anywhere. It doesn't actually have any wires leading to it. So at that point, I was kind of stumped and I was a little confused. If the thing that's supposed to be creating 5 volts, powering our Arduino, doesn't even have any wires to it, what's actually supplying the 5 volts? So then, if we go back to our data sheet for our integrated circuit and see where exactly 5 volts might be coming from, we can figure it out. Since bat switch is obviously not our 5 volt output, we then have to go and figure out what could be our 5 volt outputs. And when we do look for 5 volt outputs, we'll find that there's going to be pin 17, which is a 5 volt supply output, which supplies the VCC voltage for the 5 volt MCUs, or microcontrollers essentially. So essentially, it's an overcurrent protected 5 volt circuit that's perfect for microcontroller power supply. And what is in our Arduino? It's a microcontroller. So this is going to be one of the 5 volt power supplies for our Arduino. And then, if we just scroll down just a tiny bit more, we'll notice that we can find vProtect. And vProtect is a protected 5 volt output that tracks the VCC voltage but isolates the VCC output against shorts to ground into battery. So essentially it's intended to supply sensors which are located off of the ECU board, but it's also essentially supposed to be a protected 5 volts. That way you can make sure any of your sensors aren't getting any interference, they're not having any issues, anything like that. But essentially we figured out that our 5 volt supplies are actually going to be coming from vProtect and VCC. So that's going to be pins 17 and pins 20. So when we come back over here to Fritzing, to our PCB, we can find that pin 17 is going to be right here, and then pin 20 is just going to be right above it, right up here. Now if we zoom out so we're able to see where exactly those pins connections are going, we'll be able to notice that pin 17 goes all the way up to a 5 volt output on the top right of the board, and then pin 20 goes to the 5 volt rail on the proto area of our board. So if we just go ahead and grab our voltmeter, we're actually able to go ahead and check pin 20 by checking the 5 volt rail of our proto area, and then we can check the 5 volt circle all the way up here to check pin 17 to see if that's outputting 5 volts as well. And when I went and checked those on my ECU, what I found was that one of those 5 volt outputs was as low as about 1.3 volts, and then the other output was actually as low as about 0.1 volts, really low, which led me to believe that there was something wrong with this integrated circuit, because this integrated circuit was no longer outputting the 5 volts that it should be outputting. Because, as we all know, key switch, the 12 volt switched power, was being brought in, but it wasn't turning into 5 volts. And at that point, I was kind of at a loss because I wasn't really sure how I was going to be able to fix this integrated circuit on this board, but I had essentially figured out that there was an issue with this integrated circuit, and it wasn't supplying the 5 volts that it needed to supply to the Arduino to actually power up the ECU. So, since I was at a loss as to what to do next, I decided that I might as well go to the creator of this ECU and see if he's got any thoughts. So I ended up going to Noisy Mime, or Josh Stewart, and getting a little back and forth there, and we were able to start a little bit of a discussion, and he gave me a little bit of troubleshooting help. He basically just had me check some voltmeter points on the ECU and show him some pictures of the ECU PCB just to see if he could see any kind of obvious problems with it. But after all of that, and after basically coming to the same conclusion that I had come to, that it was in fact IC7 that was causing our problem, and it was in fact the voltage regulator circuit that was causing our problem, he ended up ghosting me after I asked him basically to see if he could repair it or kind of give me any tips for a way to repair it, or just kind of any solution. So, since Noisy Mime ghosted me, and I was kind of at a loss at that point, I decided to go to Speedy EFI. And Speedy EFI is another company that's similar to Speeduino. They're not the same company essentially, but Speedy EFI pays licensing fees to Speeduino so they can produce their products essentially. And I ended up going and contacting a guy named Chris from Speedy EFI. I was able to contact Chris from Speedy EFI over Facebook Messenger, and once I contacted him, we came to the same conclusion that me and Noisy Mime had come to, that the integrated circuit on the board was bad. So once we had figured out that it was bad, we agreed that I would send the ECU up to him to Spokane, that way he could take a look at it, see if that was the issue essentially, see if he could replicate the issue, and then see if he could maybe repair it for me. So I sent it up to him and ended up having to pay $65 for him to do a repair on the board for me. It kind of sucked that he charged me $65 for said repair, because he actually told me that he normally doesn't charge his customers for such a repair, but because I purchased from Speeduino, I would have to pay that $65 charge. Plus, I was the one who had to pay for shipping, and I actually had to pay him $10 in the first place just to troubleshoot my issue at all, which was kind of ridiculous as far as I'm concerned. Once I received my board back from Chris, this is the repair that I was presented with. He ended up running one wire from the pin 1B on our ECU connector to the pin VIN on the Arduino, essentially supplying it with 12 volt power, since VIN can get anywhere from low voltages of 5 volts or upwards of 20 volts. You could just run 12 volts to it to supply power to that Arduino. So once the Arduino was then getting switched 12 volt power, he ran a wire from the 5 volt output of the Arduino to the 5 volt proto rail of the Speeduino to then provide 5 volt power to the Speeduino. And therefore, all the other circuits are then provided with 5 volt power just because they're already connected and they're already grounded and it's already one circuit, essentially. So this was the repair that was necessary to essentially solve my issue with this integrated circuit that had went bad that was preventing my car from starting. You could also buy the correct tools to repair this integrated circuit yourself and hot air solder to actually desolder the integrated circuit from the board using a hot air soldering iron, and then using the correct hot air soldering tip, which you can find here. This is the hot air soldering tip that you would need to use. It actually costs about $50, and the main issue with this is that it takes a couple months for them to produce one for you. That's the main reason why I didn't order one to repair my ECU. Otherwise, I would have just ordered one of these to repair the integrated circuit the proper way. But it takes a little bit of time to actually receive one. This hot air soldering tip would actually direct hot air around the 48 pins of that integrated circuit and make it extremely easy to desolder it and solder it onto the board. That way, if you ever ran into this issue again, it would be super simple to solve it. Plus, the integrated circuit itself is extremely cheap. You can actually buy them for as low as $2.43, which is just incredible. $2.43 for such an integral part of our ECU. It just sucks that it takes 3 months for us to actually get this repair part. But I'll definitely be looking into purchasing one of these. That way I can look into doing these repairs myself and repairing my ECU kind of the correct way. I'll leave links to a lot of these images down below. That way, in case anyone else runs into issues where their NA6 Miata isn't starting because the ECU is no longer receiving power and they're running a Speeduino ECU, you guys can go ahead and diagnose and see if maybe it's this integrated circuit, this voltage regulator circuit that's causing your problem. And if it is, then you can actually do this bypass repair if you'd like, just to kind of get yourself by, or even do the proper repair and desolder this integrated circuit and then solder the correct integrated circuit back on. That way you've got a perfect ECU once again.